Imagine you're at home cooking in your kitchen and you spill some oil or grease from the pan. This oil or grease can then ignite and cause a large-scale fire within your home. The problem with liquid fires is that the fuel can spread out over a large area and is hard to control with water. This is similar to the BP oil spill in the Gulf of Mexico. In this experiment, we have our fuel, heptane, located in a pan on top of a load cell. With this load cell, we can weigh the amount of fuel over time and determine how quickly the flame is consuming this fuel.
What we have here on our computer is a setup of thermocouples. As you can see, working up the bar, you've got 1, 2, 3, 4, 5, 6 thermocouples. What they do is they measure the temperature just outside of the flame. Now, this is really helpful for firefighters to know, because the temperatures around the flame are what dictate to the firefighter if they can get close enough to actually put out a fire.
And what we have right here is what's called a water-cooled heat flux meter, and it measures the heat intensity of this fire that we have going on right now. Now, to give you an idea of how hot and how big this heat flux is and the heat intensity of the fire, on a given day anywhere in the world, your heat intensity from the sun might be between 1 to maybe at most 10 kilowatts per meter squared. But this fire, for example, is about 100 times stronger than that at 100 kilowatts per meter squared.
My job today is to measure the smoke that's being produced by this fire using a laser beam that shines through the smoke and flame from one side to the other. We as fire protection engineers are interested in several aspects of smoke, including how well you can see through the smoke, how much smoke is produced, and what kinds of toxic gases are within the smoke. In order to be able to get people out of the building, they need to be able to see, and this directly relates to how much smoke is being produced by the fire.
Fires interact with their surroundings, with obstructions and with the wind. And under certain situations, these fires can become very unique. In the forest fires of California, the wind through the forest creates what we call a fire tornado. We can leave 4 gaps in the corners of this model area to create a circular flow of air, which then the fire will follow to create one of these fire tornadoes.
Fire protection engineers design fire and smoke detection and suppression systems, investigate fires, and conduct fire research. The Clark School offers the only accredited undergraduate fire protection engineering program in the nation. Guided by leading faculty members, our students go on to work with top organizations in insurance, construction, regulatory policy, and state and municipal government.